Hey guys, this is Mr. Allen. What I'm going to try to do here is go through and do the examples for this review. I am going to skip the warm-up and get right into the examples so that you can have them. So example 1 says solving differential equations. So what we want here is we have a derivative and we want to make, our answer should be y equals something. So how do we undo this? Well, we do something called anti-differentiation. And if you do it on one side, you then have to do it on the other side. So dy dx is just going to become y. And then 4x is going to become, well, we got to do the antiderivative. So that'd be 4x squared over 2. So we would have y equals 2x squared. And then if you guys remember, we add the whole plus c. So that would be the solution, the general solution for this differential equation. We could graph several of these functions. So here you can see the answer again. And so let's say c is equal to 0. Well, if c is equal to 0, then you'd have y equals 2x squared. And then if we did a little, just throwing in some numbers, if we put in 0, you get 0. If you plug in 1, you get 2. If you plug in 2, you get 8. If you plug in -1, you get 2. If you plug in -2, you get -8. So this would be one solution. And of course, if you plugged in a different value, let's say that c is equal to -3, then you get 2x squared minus 3. So it'd be the exact same curve, it'd just be shifted down 3. Oops. And so then this would be here. And this one would be, let's see here, 2, 3, 4, 5, 6, 7, 8. So it'd be here, and this would be here. So then this curve would look like this. And we could keep doing this for different values of c. So that's example 1. Again, I'm going to just skip to the examples. So example 2, here we have an expression that we're asked to find. This is called an indefinite integral. And what we need to actually do here first, and this is typical with integration, is we need to ask ourselves, what does that equal? Well, that's the same thing as x minus 1 times x minus 1, which is x squared minus 2x plus 1 if you FOIL. So then our integral here, x minus 1 squared dx, could be converted to the integral of x squared minus 2x plus 1 dx. That's where this comes from. And so the antiderivative of x squared is x to the third over 3. This would be -2x, and this would be x, and then you put the plus c. So that would be the solution, if you will, for this indefinite integral. Our third example here, we have a we have a differential equation. We're asked to find the particular solution. We're actually asked to find both the general solution and the particular solution. So let's go ahead and do the general solution first. So f of x, notice I've gotten rid of the prime, would just be the integral of 2 plus e to the x. Oops. dx. And so the antiderivative of 2 is 2x, and the antiderivative of e to the x is e to the x plus c. So here's our general solution. Okay, so now we can find the particular solution using this information right here. In other words, 0.08. In other words, I could plug in a 0 for the x's and an 8 for the y, or in this case f of x. And you'd get 2 times 0 plus e to the 0 plus c equals 8. And so that's going to be 0, that's going to be 1. So c is equal to 7. And so our final answer for this, the particular solution, would be f of x equals 2x plus e to the x plus 7. On this example here, I'm just gonna let you kind of use your calculators a little bit to help you get through this, because I don't want to work out all these steps, but I'll explain it a little bit. So what you would do here to get the first several terms is you'd start with 1, so you'd plug in 1 and 1, and so then that would give you 2 minus 3 plus 4, so that would give you 3. And then the second term, now you increment that up to 2, so you would change these to 2, and you get 6, and then you get 13, and then you get 24, and then you get 39. So there's the first several terms of that sum. You would use your graphing calculator to evaluate this complete sum. That turns out to be 82,225. Just plug it into the calculator. I think it's math 10. Now to use the summation formulas, we're going to have to use, let's see here, we've got a few. We're going to have to use the sum of a constant c, which is just c times n. So you'd start from 1 and you'd go up to n. We're going to have to use this formula, I equals 1 to n of I, where I is the variable, and that's going to be n times n plus 1 over 2. And we're also going to have to use the formula n plus 1, and then I think it's 2n plus 1 all over 6. And when we do that, we get kind of the following work. Now let me erase what I did up here. Okay, let me erase that. So if I bring this down, I have to do 2 times, and now I'm going to do this, but with a 50 plugged into it. So I'm going to have to do 50 times 51 times 2 times 50 plus 1, all divided by 6, minus 3 times, and now I've got to do this here with 50, so 50 and then 51 over 2. And then finally I got to do 4 times, and I got to use this guy here, so that's going to be 4 times 50, and you'll get the same answer. It's just I didn't use a calculator there, I used those closed formulas for sums. It's actually on the next slide, but I just kind of, there's those formulas again. And then this slide here is going to use this table, this example. And we can estimate the area under that curve using left rectangles, which means we're going to use these first numbers, not the x values, but the y values. So we're going to use the first ones, that'd be these guys right here. In other words, so for 1a, you would be doing 1/2, because the difference, the dx on these is half. And then you would just start plugging in these numbers here, plus 18, plus all the way up to 15.5. We don't include the 15 when we're doing it on the left, and you'll get an answer of 69. If we use the trapezoidal rule, then we do the whole b minus a over 2n, and then we've got to do the first number once. Maybe I'll write it this way. So this is going to be f naught plus 2 times f1 plus 2 times f2, all the way to fn. This is what our formula is going to be. And so in this particular problem, it's going to be 4 over 2 times 8 times 19 plus 2 times 18.5. Let me write it that way. Plus 2 times 18 plus blah, blah, plus all the way to the end, which in this case, we actually will use that 15, and you get an answer of 68. To do the limiting process, in other words, to do the whole actual calculus-y thing, Remember that the integral is going to be equal to the limit as n goes to infinity, the summation of I going from 1 to n of f of c sub I delta x. Delta x, not dx. And in this particular problem, delta x is going to be 4 over n, because you would do 4 minus 0 over n, which is 4 over n. And c sub I would be 4 over n I. In other words, this integral is going to be equal to the limit as n goes to infinity of the summation of I going from 1 to n of negative 4 over n I plus 19 all times 4 over n. So this is the expression that I'm going to have to work out the limit for. I will leave the details to you. You will get an answer of 68, which coincidentally turned out to be the same answer that we saw on 1B. Because it turns out that this thing is just a line. It's just a line with a slope of -1 and a y-intercept of 19. And we're going to 4, starting at 0. So it's really just this trapezoid here. And so you could calculate its area by using the formula of 1/2 height base 1 plus base 2. So it'd be 1/2 times 4 times. Now you gotta, this distance here, that's base 1, let's say, and then base 2. Well, if you plug 4 into that, that'd be that 15. And again, you'll get the answer of 68. And last but not least, I'm going to just kind of give you the answers to these. So this is properties of integrals. So if I'm going from -2 to -1, so I'm going from -2 to -1, I'm essentially asking what's the area of this triangle that's above the x-axis. So it'd be 1/2 times 1 times 3 times 3 over 2, so it's 3 over 2. The second one is going from -1 to 1, so we're talking about this area here. Notice that it's under the x-axis and it's half of a circle with radius of 1. So we know that the radius of the circle is pi r squared, but it's half of that. Furthermore, it's below the x-axis, so this is going to give us a negative result. And so we get negative pi, and then the radius is 1. So it's negative pi over 2. And then the rest of these answers, this one turns out to be 1, this one turns out to be 8, and this one turns out to be pi over 4. This one. And these absolute values are going to make anything that's below the x-axis become positive. So it's basically going to take this triangle here and it's going to flip it over, and then we're going to only get a quarter of the circle instead of half of the circle. So everything just makes it positive.